Alright, hello everyone, welcome to the OneClass channel. My name is Andrew and I'm doing statistics as a mathematics at University of Toronto. And today we'll be going over some common mathematics questions at both the high school and college levels. And if you need some homework help or tutoring, please check out the links in the description below. So now let's start our session. Cool. Oops. Okay. So our first question today is asking us what are coterminal angles. So let's write it out. What are coterminal angles? All right. So coterminal angles that are just two angles that have the same initial and terminal size. So I'll write its characteristics in the point form. So same initial and terminal side. And also they're joined the standard form, which means the initial side is on the positive y-axis. So initial side is on the y-axis, positive y-axis. And we can easily find coterminal angles by using any angle, then adding or subtracting another angle by 360. So adding or subtracting another angle by 360. And here are some diagrams to help you better understanding this part. So let's build a xy axis first. So let's say I got a 30-degree angle, right? So look like this, and its coterminal angles will be, I'll use another color, will be negative 330. And also there's another one which is 390. Oops, stuff from here. Right. And also if we have let's say we build a 40 degrees angle, 45 degrees angle, its coterminal is going to be 315. Something look like this. Three, 1, 5. And also 405, which is just 45 plus 360. So we just rotate it one more time. Yeah. So, but always keep in mind that in your question or your practice problems, they might give you the range of the angle. So it might give you something like, once you find the angle between, let's say, negative 360 to 360. So in this case, we need to eliminate the 390 and 405 because they are go over the range. They're not included in this particular range. Yeah, so just keep in mind. Yep. So I think that's pretty much what coterminal angles are. And let's leave a comment there. Job. Correct. Alright, so the second question is asking us how many pounds is a gallon of water? So let's copy down the question. How many pounds is a gallon of water? So first our conversion factor. So 1 US gallon of water was approximately 8.35 pounds. So let's write it down here. So 1 gallon is equal to 8.35 pounds. Yeah. And this conversion is mostly accurate at room temperature. The exact amount of pounds in a gallon of water varies as the density and the temperature. Yeah. Already on the site. Other factors. Density. Room temperature. Yeah. So 1 gallon of water is equal to roughly 8.35 pounds. So if the question asks you how many pounds is 5 gallons of water, so we just need to times 5. Because now we have 1 gallon, 1 gallon is equal to 8.35. And if we increase to 5 gallon, that means we need to times each side by 5. Because that's 5 times bigger. So same thing on this side as well. We need to use 8.35 times 5 pounds, which is equal to 8.35 times 5, 41.75 pounds. Yeah. So whenever you come across a question that asks you to convert one unit to another, always need to find the conversion factor first and then just do your calculation. Yep. Oh, and don't forget your units. Yep. So I think that's all we got for this question. All correct. Okay. So coming up, we have a question asking us what is exponential notation. What is exponential? Exponential notation. Right. So exponential notation is just another way of expressing numbers, and let's write it in here. For it is written in the form of a to the exponent of n. Yeah. So which is a little n on the right top of a. And in this case, it just means a is multiplied to itself n times. A is multiplied to itself n times, which just means a times a times a times a times dot 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 times a, and there are n of a in total, and we just times them together. And second thing is, in this case, a is what we call the base. Well, n is our power, or is it exponent, or is it index? So the power, exponent, or index. Right. So if I say 2 to the exponent of 4, in this case, 2 will be our base, and 4 will be our exponent. So that's like an example of it. Alright, so coming up, if we got a, let's say, 3 to the exponent of 4, which is equal to 81, then it is just equal to 3 times 3 times 3 times 3, right? So we said it is multiplied to itself n times, so in this case it will be 3 times itself by 4 times. So 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. Right. And also here, 81, we can also express as the product of its prime factors, which is just 3 times 3 times 3 times 3. And we know 3 is a prime number. Right. And yeah, so the second part of the exponential notation will be what we call the scientific notation. I'll write it down here. Scientific notation. Yep. So it is a specific example of exponential numbers where 10 is almost always used as a base number. So let's write this down. A specific example of exponential numbers where 10 is almost always used as a base number. It's the base number. Right. And yeah, so to convert a number into a scientific notation, we express all such number as a coefficient between 1 and 10, and followed by an appropriate power of 10. So I'll write this down, and then I'll give you an example of that. So to convert a number into its scientific notation, we express all such number as coefficient between 1 and 10, followed by a property power of 10. Okay, so now if we say we have an integer 138,000, so this we can, in scientific notation, we can rewrite it as 1.38 times 10 to the exponent of 5. Right. And you can see for this part, 1.38 is between 1 and 10. And for the second part, it's just a proper power of 10. And so if we have, like, say, 138 times 10 to the exponent of 3, this is not going to be correct since the first part is greater than 10. Okay? Yeah. So here we express, I'll move it on the side. So this is correct. Yeah. So here we express our coefficient as a number between 1 and 10, and hence we need to have only one digit to the left of our decimal point. Yeah. So I'll write it on here. So 138,000 is equal to 1.38000 times 10 with exponent of 5. And the reason why is exponent of 5 is that we imagine there's a, oops, change the color. We imagine that's 138,000.0 is equal to the right hand side. And now we need to move the decimal 5 times in order to get 1.38. So that's 1, zoom in a bit. So that's 1, 2, 3, 4, and 5. So the decimal point will move to here, and that's exactly what we want, 1.38. So therefore, the exponent should be 5. Yeah, so we go 1.38, and then we count the decimal. Let me write this down. So we get 1.38, and then count the decimal places from the rightmost digit up to the first digit. And that will be the exponent. Be the exponent of our base 10. So let's do another example. If we have, let's say, 0.00058. Yeah, and now I want to convert that into a scientific notation. So how are we going to do that? So first, this is going to be equal to 5.8 times 10 with exponent of -4. Right. So here we express our coefficient as a number between 1 and 10, and hence we need to have only one digit to the left of our decimal point. Oh, and so same thing here. If we say I got a 58 times 10 to the exponent of 5 and of -5, this is also going to be not incorrect. Not correct, since this part is greater than 10. We always need to make sure that the coefficient is between 1 and 10. Okay? So let's do the decimal moving. Right. Okay. So in order to get a 5.8, we need to move the decimal point to the right for a certain unit. And now let's see how many units we need to move. So the original decimal point is right here. It's right here. So that's going to be 1, 2, 3, and 4. So it moves to here, 5.8, and that's exactly what we want. So we got 4 there, so hence the exponent should be -4. Alright, so I'll write this down. So we get 5.8, and then count the number of decimal place from the original location of the decimal point and that will be the exponent of our base 10, but will be negative. Yeah. Okay. So if this number is less than 1, after we converting them into a scientific notation, the exponent of 10 is always going to be negative. And if we got this part, like 1.38, like the example we have about, this part is greater than 1. So in this case, if we want to convert this into a scientific notation, the exponent of 10 is always going to be greater. It's always going to be positive. So I can see there's 5 there and -4 there, right? So yeah, so I think that's all we got for this question. And let's leave a comment here. Oh, correct. Good job. Right, so coming up, so we need to find out the value for sine -pi/2. So before jumping to this question, recall that there's a property that sine -x is just equal to negative sine x. We can just take the negative sign out. Therefore, if we calculate this sine pi over 2, this is going to be equal to 1. Since if you want to draw down the xy axis, that's going to be 0, 1. And that's pi over 2. So here, sine pi over 2, it's just going to be 1 over 1. So it's still 1. Right. So by knowing the value of sine pi over 2, we can put it back to the formula, which is a property we have about, which is sine negative pi over 2 is equal to negative sine pi over 2, which is negative 1. Right. So the value of negative pi over 2 is just negative 1. Yep. So that's all we got for this question. Let's leave a comment here. Oh, correct. All right. So our last question today. So how many pins are in a gallon? All right. So in the British Imperial system of measurement, there are eight pins in arrow. I mean, in 1 gallon. 8 pins in 1 gallon. Or we can also rewrite it as the form of our conversion vector, which is 8 pins is equal to 1. Right. So that's our conversion vector. So if we want to find out how many pins in 4 gallons, we just need to do 4 gallon times 8 pins 1 gallon, and this is going to be equal to 32 pins. So this is for how many pins in 4 gallon. Yep. So always find your conversion factor first, and then just do your calculation. And let's leave a comment there. Correct. Yeah, so these are all the questions for today, and if you enjoyed today's Q&A and would like to be notified of when we do this next, please hit the subscribe button and notification bell below. And if you'd like to submit your own questions, please read the links in the description. Remember to leave a like and a comment and share the video with your friend. And this has been Andrew from OneClass. Hope to see you soon.